Hello, this is question 9 on your January 2023 Edexcel International paper. It's the AES paper, so you should be able to do at the end of year 12. It looks more difficult than it is, but you have curve C, which is this one, is a quadratic. This is the equation, and the line L with equation y equals 2, which is this horizontal line. So this point is 2. We can mark that. Then the curve C intersects the y-axis at point D, so here. And the first thing they ask is write down the coordinates of D. D is the y-intercept of my quadratic. So if you see your quadratic, the y-intercept is 5. So it's y when x is 0, 0, 0, 5. So the coordinates of the point are going to be 0, 5. That's the first thing I'm going to do here. So for A, coordinate point D is 0, 5. And that's the first thing. Then the curve C intersects the line L at points E and F. So this point and this point here is the intersection between the quadratic and the line. Find the x coordinate of E and the yx coordinate of F. Because we know the y coordinate is 2, so it's what we are going to find is the intersection between the quadratic and the line. So we are going to solve simultaneous equations between these two, the equation of the quadratic and the line. So I have for B, the quadratic is y is x squared minus 4x plus 5, and y is 2 plus 5, and y equals 2. So I can solve these simultaneous equations however I want to. I would do y here equals 2. So I have 2 is x squared minus 4x plus 5, which means that x squared minus 4x plus 3 is 0. And when you factorize this expression, you have x minus 3, x minus 1 equals 0. I would do this with a calculator to not make mistakes, but I would write this factorizing thing, yeah? So my solutions are going to be x equals 1 and x equals 3. That means those are the x coordinates of the point. So x equals 1 will be the x coordinate of E. So this is point E, and this is point F. Yeah, so those are the x coordinates. Is 1 mark for each coordinate. Then shown that the shaded in figure 3 is the region 1. R1 is bounded by C, L, and the y-axis. So R1 is bounded by the y-axis, the line y equals 2, and C. So this is R1. And R2 is bounded by C and the EF and the F. So is this lighter shaded region, yeah? And we need to show that the area of R1 divided by R2 is a constant, and we need to find the value of the constant, yeah? So we are going to find this area, and then divide them to see what K is. R1 is this area here. So what we can do is to integrate our curve C, so this bit here, sorry, between, we know this point is 1, this x, so between 0 and 1. If we do that, we're going to find this area here. And then we can subtract this rectangle, and this rectangle is 2 by 1, so it's quite easy to do that. With these questions, so when you have one line and another line, and you know both equations, so this one is y1 equals wherever, and this one is y2 equals wherever, we if we want to find the area trapped between them both, we can integrate between 0 and 1, the top one, so the one that is above, y1 in this case, minus y2, yeah? So we can do that straight away. So integrate the difference between this line and this line, and then we don't need to subtract this one because we are finding just the area straight away. Or we can find the whole area and then subtract the rectangle. Yeah, it's two methods, you're going to get the same either way. And I think sometimes you get confused with that because you see the mark scheme and you don't know what they have done. So you can integrate y to 1, so the quadratic, and then subtract the area of the rectangle. Yeah, so either way you're going to get the same thing. I'm going to do this way because I think it's faster, or I can show you both. So I'm going to integrate y1, so the quadratic, minus the line. If I subtract the y of the quadratic minus the y of the line, I have this minus 2, so which is this plus 3. Yeah, I'm subtracting that. So I'm going to integrate. For c, I'm going to integrate between 0 and 1, x squared minus 4x plus 5 minus 2, which is 3. So I'm integrating the difference, yeah, between my two curves. And that's the case with any two curves that you have. So if you have one equation of a curve doing this and another equation of the curve doing this, you can find this area integrating the difference between the one that is above, which is this one, and the one that is below. Yeah, you always can do that. So here I have x cubed divided by 3 minus 2x squared. I'm just integrating plus 3x between 0 and 1. And when you substitute the values 0 and 1, you have 4/3. And that's the area that I'm finding, yeah, R1. If you want to do the other way, so I'm going to do it quickly. I can integrate between 0 and 1, the quadratic, so x squared minus 4x plus 5. You integrate this function, and then you have x cubed 3 minus 2x squared plus 5x between 0 and 1. You get 10/3. And then you can subtract the area of the rectangle. The area of the rectangle, we said, is 2 by 1. So the area is 2. And the area is 2, which means that R1 is going to be the total area. So this blue thing that I have here, which is 10/3, minus the rectangle, which is 2. And this is 4/3 again. Yeah, like I found before. So you can do this way, subtracting first, or this way, subtracting after. I tell you just because sometimes you get confused with the mark scheme. And R2 is this area here. This area here, you could do, for example, this triangle, this big triangle. I know this D is 5 because it was the y-intercept. So this length is going to be 5 minus 2, which is 3. And this is the coordinate of F that was 3, I think. Yeah, 3. This is 3. So we know the dimensions of the rectangle, and then subtract R1 that we just found. So this triangle, I think I said rectangle before, but this triangle is 3 times 3 divided by 2. Yeah, so the area of the triangle is 3 times 3 divided by 2, and then I can subtract R1. So I have 9/2 minus 4/3. And this is 19/6. So this is R2. So the quotient between R1's was R1 divided by R2. So it's going to be 4/3 divided by 19/6. And this is 8/19. Yeah, and that's the constant that I was looking for. And that's all with this question. They just asked me that constant. Yeah, that's all.